Hello students, in this video we are going to discuss 5.21, 5.22, 5.23 from work energy and power as per new textbook. Here 5.21, what the data is given, the blades of a windmill sweep out a circle of area A. If the wind flows at velocity V perpendicular to the circle, what is the mass of the air passing through it in time t? We need to find out mass. And what is the kinetic energy of the air? Kinetic energy we need to find out. Assume that the windmill converts 25% electrical energy and that A is equal to 30 meters square, velocity V is equal to 36 kilometers per hour. That means the wind is traveling with the speed of 36 kilometers per hour and density of the air or wind is 1.2 kilogram per meter cube. This is the data given. So what is the electrical power produced? Here we need to find out the power also. This is somewhat lengthy but will come one by one. You can imagine it with our daily life situation. First of all, we need to find out the mass of the air passing through the windmill. So mass here I will write in terms of density into volume. Y means density is equal to mass by volume. Why I am writing here? Here we have the data in terms of area, in terms of density. That's why I have written this one. So this density is equal to, mass is equal to. So this density into volume directly we don't have, but we have in terms of area. So area into, we can write distance covered by the wind. So I am writing area into velocity into time taken. This one will give us volume. So that is equal to rho A V T. So this is in terms of given data. Here time we don't have, that's why we are writing the mass in terms of rho A V T. We have rho value, we have A value, we have V, but we don't have the time t. So we are leaving this one in terms of rho A V T. While coming to B, what is the kinetic energy of the air? So the kinetic energy is equal to half mv square. That is half m into m value is nothing but we have rho A V T and v square. That is equal to half rho A V cube into T. This is the kinetic energy of the air. While coming to C, assume that the windmill converts 25% of wind's energy. That means in this energy 25% is converted into electrical energy. So therefore what we can write here, so 25% of the kinetic energy I am writing here Ke dash, that is equal to 25% of Ke, that is 25 by 100 into half of rho A V cube T. From this we can write this value as 25 by 100 is nothing but 1 by 4, that is 1 by 8 rho A V cube T. This amount of energy is converted into electrical energy. Now electrical power. So electrical power is equal to kinetic energy divided by time taken. From this time is coming towards left, that value is equal to 1 by 8 rho A V cube. Now except the time, remaining terms we have. So we can calculate this power value. So 1 by 8 into density of air is given as 1.2 kilogram per meter cube into area 30 meter square into velocity 36 kilometer per hour. So we can write 36 kilometers per hour is equal to 36 into 5 by 18 meters per second. That is nothing but 10 meters per second. We can write 10 square. So after simplification, we will get 4.5 into 10 power 3. Here electrical power, the SI unit will be watt. That is also nothing but 4.5 kilowatt also we can write. This is the answer for 5.21. Mass, kinetic energy and electrical power produced. Coming to 5.22. A person trying to lose weight lifts a 10 kilogram mass 1000 times to height 0.5 meter each time. Assume that the potential energy lost each time she lowers the mass is dissipated. That means she is lifting 10 kilogram of mass to height of 0.5 meter and lowers. Like this, how many times raise? 1000 times. How much work does she do against the gravitational force? First of all, we need to find out work done by her. Next, fat supplies 3.8 into 10 power 7 joule of energy per kilogram. That means 1 kilogram of fat supplies 3.8 into 10 power 7 joule, which converted into mechanical energy within 20% efficiency rate. How much fat will the dieter use up? That means the amount of fat consumed or melted we need to find out. Coming to this one. Here, so amount of work done is equal to, generally we have mgh. One time the mass is lifted, mgh. But here 1000 times it is happened. So I am writing it is n times of mgh. That is equal to 1000 times of mass value is 10. Suppose if you are taking g value 9.8, we can take 10 also into 0.5 meter. After simplification, 49,000 joules of work is done. Now coming to B. So 1 kilogram of fat gives 3.8 into 10 power 7 joule in the 20% efficiency. So what we can write? Mechanical energy supplied by what? By 1 kilogram of fat is equal to 20% of 3.8 into 10 power 7 joule. So this one we can write 20% means 20 divided by 100 into 3.8 into 10 power 7. After simplification, we will get this value is 76 into 10 power 5 joule will get. Observe carefully, A is in terms of joule, it is also in terms of joule. Both are having the same units. So dimensionally, what we need to find out? How much fat will the dieter use up? That means amount of fat consumed or burnt we have to find out. So therefore, we can write fat consumed for 49,000 joule of energy can be taken as 49,000 divided by 76 into 10 power 5. That is equal to, we will get 6.45 into 10 power minus 3. While coming to the units, how it is? It will be in terms of kilogram. The reason is fat consumed for 76 into 10 power 5 joule of energy is equal to 1 kilogram. So, the ratio of work done to mechanical energy is nothing but amount of fat consumed. Coming to 5.23. A family uses 8 kilowatt of power. Direct solar energy is incident on the horizontal surface at an average rate of 200 watt per square meter. Actually, it is nothing but intensity of light, solar energy. If 20% of this energy can be converted to useful electrical energy, how large an area is needed to supply 8 kilowatt? So, to produce 8 kilowatt hour, how much area is needed? So, here area value we need to find out. Compare the area to that of roof of typical house. Okay, it is the ratio of with respect to one more area we need to find out. First of all, coming to part A. Here area needed to supply 8 kilowatt is equal to, assume that A meter square in terms of SI system. Energy, here actually we can write it is rate of energy incident per unit area is equal to 200 watt. This is also the data given. Therefore, energy incident on area, it is also nothing but rate of energy incident on area is equal to, on area A is equal to 200 into A in terms of watt. Therefore, here but 20% of energy only is converted into electrical energy. Therefore, electrical energy is equal to, there is a rate of electrical energy is equal to 20% of 200 A. That is nothing but 20 divided by 100 into 200 A. That is nothing but only 40 A watt. That means only 40 into A watt is in the form of electrical energy. But for the house, how much amount of energy or power is utilized? 8 kilowatt hour. So what we can write here, but 40 A watt is equal to 80 kilowatt. That is nothing but 8000 watt. From this we can write A value is equal to 8000 divided by 40, that is 200 meters square. That means practically you try to connect it to produce 8 kilowatt of electrical energy, 200 meters square area is needed according to the given data. Now, compare this area to that of the roof of typical house. Here, while coming to B, area of the roof of the given house, assume that it is some A dash, that is equal to 70% of, here he has given, but it should be some data is missed here. 20 meter into 15 meter is given. So we will use this data here. So 70% of 20 meter into 15 meter, that is equal to 70 divided by 100 into 20 into 50. This value will be 210 meters square. Therefore, what we can write, the required ratio of areas, that is A divided by A dash, is equal to 200 divided by 210. This value is nothing but 20 is to 21. The problem is look like lengthy, but be careful with the given data. Okay, thank you. So this is the way of writing the solutions for the given 3 questions. Please subscribe the channel and share it. Thank you.